In this video, we are going to discuss problems that involves work done by the spring. So in each of these problems, we are going to use the rule for the work done by the spring, which is W equals half kx squared. Let's start with problem 5.42. The question says, an ideal spring has a spring constant K equals 440 Newton per meter. Calculate the distance the spring must be stretched from its equilibrium position for 25 joule of work to be done. So let us write down what the question has given us and what it needs us to find. We have the spring constant K, which is 440 Newton per meter. We have the work done, which is 25 joule. We need to find the distance the spring must be stretched. So we need to find what is x. We know that work done by the spring is given as half kx squared. And if I want to find x, I need to rearrange this term to find x. So we write x squared equals multiply with 2 and divide by k. 2w over k. And x will be equal to square root 2w over k. When you substitute the values, you get square root 2 times 25 divided by 440. That gives me the value of x as 0.34 meter. In the next problem, we have a spring that is stretched 5 centimeter from its equilibrium position. If this stretching requires 30 joule of work, what is the spring constant? So we are going to be using the same rule, but this time what we are finding is different. So the given quantities are x, which is 5 centimeter. I will convert this to meter by dividing 5 with 100. That will give me 0.05 meter. I have the work done, 30.0 joule. I want the spring constant. So let's use the same rule. Work done equals half kx squared. This time we need to find k. So we will multiply with 2 on the other side and divide by x squared. So k will be 2w over x squared. And when you substitute, 2 times 30 divided by 0.05 squared, that gives me the value of k as 24000 Newton per meter, or 2.4 times 10 to the power 4 Newton per meter. So whichever quantity the question wants you to find, you can always rearrange the terms to either find x or k. Question 5.4. Here you have a spring with a spring constant k that is initially compressed a distance x0. So this is my compression, the initial compression of the distance spring by a distance of x0. After returning to its equilibrium position, the spring is now stretched by a distance x0. So first the spring was compressed and then the spring was stretched. You need to find what is the ratio of work that needs to be done on the spring in the stretching to the work done in compressing. So question wants me to find what is the work done, the ratio of the work done when you are stretching the spring to the ratio of work done when you are compressing. We know that work done by the spring is half kx squared. This work depends on the displacement from the equilibrium position, which is my x. So in this situation, the displacement for compression, I'm going to write it as xc, which is negative x0. Compressions, we generally take it as negative. And the displacement for stretching, I will write as xst, which is positive x0. Displacement from equilibrium position, whenever you compress the spring, we take them as negative. And when you stretch the spring, you take them as positive. So this ratio, I can write as half k x0 squared over half k negative x0 squared. Now we know when we take the square of a negative number and the square of a positive number, if these two numbers are same, it's going to be equal. So I get half kx squared on the top, half kx squared on the bottom. Since both of them are the same quantity, you can cancel them. And when you cancel them, you get the ratio of work done during stretching to work done during compression to be equal to 1. This is the ratio.